Hi, and welcome back to the Inflatable Vehicle project. This is the third episode, so if you don't get what I'm talking about, you need to see the first episode. I have just finished off the control handle, the cordless drill hack, which gives me control over right and left side of this vehicle. And I have also incorporated a third PWM circuit here. It's a simple DIY circuit. I will show you later on how that works. Which gives me fine-tunable control over the two vacuum cleaners that are filling up the tires with air. Since it's a simple 555 timer, it goes from like 5% to 95%, but it's no off, so I need an off switch for that. And the two other off switch I have here is actually just switches to power up the relays that give me the reverse function on the vehicle so that I can make on the spot turning and going backwards. And I also have, of course, incorporated a connector here so that I can hook it up to the vehicle itself. So what's left to do basically is to mount the counterpart on the vehicle itself and of course hook up the wires to the relays and to the 4 transistors that are handling the high voltage for the motors. And I have some basic assembly, mostly just screwing parts together. And then I'm ready for the actual all-up first full test, which I'm really looking forward to. Where I will inflate all the vehicles, all the wheels of course, and I will just make sure that the input I give on the controllers here are actually generating the output I want, so that I'm going in the direction that I want to, and hopefully I will be able to at least ride a little bit in the backyard, just trying the system out and see if anything goes wrong instantly, or if I can have a bit of fun just to start with. But before we jump into that's for the next episode, I would like to rewind and take up this video where I left off in the last episode. And the last episode was about gaining knowledge about this power tool hack. So I was doing more tests with the utility vehicle, and I found out that I needed to upgrade my relays that control the reverse function to a more heavy-duty relay, so I did that. And also I noticed in the utility vehicle that the torque from the power tools was so tremendous, so I needed to upgrade the motor mounts on this vehicle as well, so that I don't have to take everything apart the first thing I do and redo it. So I have 4 of these 6mm bolts going straight into the axle from the motor mount, helping with the torque transfer from the motors to the axles. Before I only had clamped the motors in place, but now I have 16 of these bolts taking care of that. So let's check that out as a start. Once those 2 modifications were incorporated to the vehicle, I started to draw wires to the motors through the axles. It's a little bit tricky. Everything has to be fairly airtight. It looked like this. And if putting those wires through the axle were tricky, an even more trickier episode is to finally seal each wheel. And the trick is to apply this tape from the inside while you're closing a zipper. And of course the hardest part is the last 10 centimeters. But it works if you have patience. In the beginning I'm using longer strips and closing the zipper and taping it from the inside. And the closer you come to the end of the zipper, I'm using shorter and shorter pieces of tape. And at the very end I'm using ruler, and so I'm just sort of sliding the tape onto this ruler and pushing it up from inside, and it did work, but it's really tricky the last centimeters. It looked like this. The last part there, that was the actual speed of things, really did look like slow motion, didn't it? Okay, so the next step was to start wiring things inside of this beast, and also I needed to heat up the air hoses here because they were taking too much space. It's a very thin chassis, so I had to heat them up with the air gun and reshape them. Designing a seat for this vehicle was kind of tricky because I really don't know how I'm going to use it. I was first contemplating other possibilities, perhaps standing on it or riding it like a ATV with a saddle in the middle. But I went for a seat anyway, and I opted for a foldable one so that I can fold it down like this so that I have a fairly flat surface so I can mount other gear on it instead of sitting on it myself. And I think you can sit 2 adults on this seat. It's just barely, but I think it will do. And the 1 adult and 1 kid for sure. The construction process is pretty straightforward. It looks like this. And now let's roll back and see how I did the hack of the 2 battery-powered electric drills and what I found out when I was doing the hack. Now I have just finished the hack of the battery-powered drills. So I have the motor cables coming out of the part here, and I have the an extra cable with it's just connected directly to the battery here. I'm going to use the 12 volts in this wire to switch the relays that controls backward and forward rotation of the motors in the inflatable car. So before I hook this up to the rest of the system, I of course just want to check that I have a good PWM signal coming out of these wires. And when I did that, I discovered that I have a frequency of I don't know if it's visible. This screen here shows 1 millisecond, and I have 5 peaks, so it's 5 kilohertz in this PWM circuit in this machine here. And it is, if I remember correctly, I had 3 kilohertz coming out of the slightly different battery-powered drills that I use. I'm using it to control the utility vehicle. Those were slightly simpler and cheaper drills, and the reason that I do not use them for this build is because they were out of stock at the time. So I really would like to keep the setup exactly the same as in the utility vehicle. But anyway, I'm always in a slight hurry, so I bought the ones that they had on the shelves, the cheapest one on the shelves, and they seem to be running slightly higher frequency. So I just want to make sure that it still works well with the high voltage transistor that I set up here. So let's do a couple of high voltage tests. And now I have the vacuum cleaner here hooked up to the high voltage transistor, and the gate and the ground is hooked up to the oscilloscope. And here's my hefty battery pack. It's slightly over 1 kilowatt hour of usable energy in there at 260 volts. And I have my PWM hack here, the 5 kilohertz test, and I have a simple clamp amp meter on the cables going to the transistor, so we can have a number of the power going through the system. The good thing with vacuum cleaners are that they are, so to speak, under load all the time, so there will be a significant amount of power running through the system. Okay, let's give it a go. So it's around 200 watt running through the system right now at these PWM settings. I'm increasing now. Now we're up to somewhere around over 400 watt, and the vacuum cleaner is buzzing off. Okay, let's go full throttle. It's just a straight line there. So this would be somewhere around 1000 watts or so. Yeah, it seems to work. Now I have changed the settings slightly on the oscilloscope so that we can examine the waveform of the signal better, to see if there's a lot of sloping in the turning off phase, and how the turn on phase looks like. Let's see here. So you can see it's a slight oscillating turning on, and the turning off is, it's not a perfect waveform, but it's pretty good. And each square is 2 volts, so it's pretty precisely 12 volts over the gate, which is supposed to be able to switch the transistor forcefully and efficient. Now I have disconnected the battery pack, so I can feel the temperature here, and it's well, I would say it's perhaps 34 degrees or so. Let's try a different load. So on the topic, what could possibly go wrong, let's just try out this setup. So it's a ordinary corded drill hooked up to the PWM circuit and the battery bank. And it's a propeller. It's a what is it? It's 24 by 8, so it's not super large, but it's large enough to make this interesting. Of course, safety goggles. It will save me from anything that could possibly happen. Okay, let's see here. I think it's good. Nope. The wires here. PW thing. Okay, yeah, right. So obviously I need to, to have this completely compressed, this trigger here, and I have my second trigger here to control the power. Yeah, that's better. Okay. Yeah, starting to blow. It's getting better. Now it's a breeze. Good signal. Yeah, it seems to work. The 5 kilohertz PWM signal coming from the motor wires from this machine here seems to be able to drive the high voltage transistor fairly efficient. However, I do think it did heat up a little bit more than with the 3 kHz signal coming out from the cheaper battery powered tools I use for the utility vehicle. So I'm not perfectly happy with that, but I will give it a go with these just for a start with the inflatable car. So I'm going to use 2 of these to control either side of the inflatable vehicle, but I'm going to build my own PWM circuit for the vacuum cleaners, because I do want to have a more fine-tunable control over those motors, because if they were to run too high, the wheels will simply burst, and I really want to avoid that. And it might turn out that it's just an overall better idea to build your own PWM circuits from scratch, but this is a very quick solution to get going with your project. Another note on that is that you of course have to make sure that you have turned the rotational switch in this setup in the position where you actually have positive voltage on the red wire. Since the machine is supposed to rotate both ways, it's a simple switch here that actually changes the polarity on the motor wires. So make sure that you have secured the switch in a position where you actually have positive here, so that you don't try to drive your high voltage transistor the wrong way around on the gate, because that will probably be a very bad thing. Okay, so let's get going with the experimental board PWM circuit build. Now I have completed the build of the simple PWM circuit. It's based on a 555 integrated circuit with a couple of the surrounding components. And I have turned on my power supply, and let's check out the scope, how the signal looks like. I think you can see it there. I'm going to turn up. It's supposed to be between 5% on and up to 95% on time. You can see it's slightly overshooting, but it's not that bad, and it has a little bit of a radius down in the bottom, but I don't think it's that bad. This is full power, and now I'm going back, and you can see that the wave is getting a shorter period of on and a longer time of off. So I think that it looks pretty good. It's 600 Hertz, so it's just 1/10 of the frequency of the power tools. But I'm going to try to drive the high voltage side of this with this simplified PWM circuit, and hook up the vacuum cleaner to see how it works. And here you can immediately detect the downside with this circuit. It does not have a off state. It's always slightly turned on, so I can hear a slight humming. Let's turn it up here and listen to it. Well, I think it performs well so far. Let's go full throttle. It works. I have fine control over the power setting of the vacuum cleaner. It's a much more defined control than the triggers on the PWM hack in these machines. But the transistor heats up more with this 600 Hertz homemade circuit than the professional made circuits in these ones. So that's the backside. But I just double the transistors and have air to blow over them, and I think that will work good enough for a start at least. And that takes us back to the starting point of this video. Let's just take a look underneath the hood, so to speak, and see what's under here for right now. So I was talking about having perhaps forced air going over the transistors for controlling the vacuum cleaners, but I opted just for a big heat sink. I think that will do good enough, and it's a vent hole here, and it will come in air here that gets sucked in by the vacuum cleaner motors. Yeah, you can see the wiring here. It's not beautiful, but I think it will do for now. This is glass fiber reinforced tape here, and I have used just clamps to hold it down, so I think it's good enough for now. So here I'm going to wire the switches for the relays, and all these thin wires are for the PWM signal that's going to the gate on all transistors. And you can see the air hose, which I shaped by heating them up slightly. So it's not much left now, except for just finishing this up, mounting everything together, and perhaps cleaning up the wiring here. I'm thinking about wrapping tape around here to get a softer feel and a less conductive feel as well. Since it's a high voltage system, it's always a good idea, I think, to try to isolate everything from the human body. Okay, so if you like the content, please consider subscribing so that you don't miss the next episode, where I hopefully will do a all-up test in the garden and inflate the wheels and try the control system and see if it works. I'm very I have a good feeling, and I hope it will end well this time. This is probably like version 1, and just as with the chair, I suppose it will be like 3 versions before it works really well. But I still have good hopes. See you.